This is a video about making polyhedra pendants using a 3D printer and some software tools and a bit of craft skills to put it all together. So we're looking at a SketchUp file window here, and we'll come back to this in just a second. First, this is the type of thing that you can produce. This is a 37-sided shape. Notice that the 3D printed shapes are connected with dowels that go through hinges. 2 hinges are attached to the bottom of each of these shapes. And now I'll show you the bottom of these shapes. The bottoms of the shapes I just showed you, as you can see here, are flat. So the hinges attach well. And in the center of each of these triangles is a 3D printed sort of lifesaver shape with a 1/2-inch hole in it that perfectly holds these Adafruit RGB LEDs, programmable RGB LEDs. And so you can get all of the shapes to light up and change colors with your program that you run on an Arduino. Okay. So how to do this? Well, you can get regular polyhedra off of the SketchUp warehouse. If you're really good at SketchUp, you can make your own. You don't need to use regular polyhedra. You could use irregular, so just like I did in what I just showed you, though that wasn't really a polyhedra. But this is a icosahedron. It has 20 sides, so this would be good for a classroom project. Now, I've already made 2 of the shapes here, and but so I'll just continue on with a third. So I select a side here, then I do Edit, Make Component. Since this is the third face I'm working with, I'm just going to call it F3, and I'm going to do Replace Selection with Component. Now I'm going to make a copy of that. Just pull a copy. Whoops. I have to press the Option key. Now I'm going to make a copy of that. Now there's this wonderful little SketchUp tool called Align, which allows me to easily take a surface and align it to the XY plane, or to any other plane, really. In this case, the XY plane. So I click on 3 points to define that plane. And I come down here and click 3 points that I want those to match up to. And it moved that shape down here. Now here's the cool thing. Because this is a component, any changes I make to this shape are also made up here. So you can see what's happening as you do it. So I will I'll go through quickly making one of these shapes because there's some tricks that are useful to know. I've discovered that through trial and error that this process is most helpful, just giving some triangles on this surface that I've push-pulled off of the bottom. And this is a if you don't do this, you get sort of like from the base here as into the shape, you get a real like shallow gradient before you start going up. So I found that helps. Anyway, you can experiment. So the tools then that I use to alter the shape, the proxy of the ultimate shape, are these 6 tools, pretty much. Just a combination of those allows you to get some interesting variety in your shape. So what I'll do now is I'll just rotate it a bit, very small amount. You don't want to do big rotations. I'll do like 4 degrees, okay? And you can do things like take a line and size it just to give some variety, or you could take a line and oops, just change its angle a bit. Again, yeah. What you want to watch out for is anything that causes a line to appear in this top plane, because that then makes further push-pulling of that plane impossible. So right there, you see how got these two lines here and here. Don't want that, so I'm going to undo that. But if I went this way, you're going right along the plane, making a change along the plane, so it's not going to create those lines. Okay? So I'm going to go pretty quickly here. I would do more interesting stuff, but just for the purposes of this video, I'll keep it relatively short. If I hold down the Option key, I'll change the size around the center point. Now this box here represents the MakerBot Replicator 2 build plane, builds a box. So I know that I can't go any higher than this line. In fact, I'm going to keep it about an inch below that line. So again, you can spend as much time as you want on this. I'm going to go fairly quickly here. And just the quality of the shape or the interest of the shape depends on how much time you take and what sort of changes you make. And so I want to go to about here, so I'll just come up to like about that point. And now I'll close this in pretty sharply. And I'd like to here do a little trick with this so that I get a point here. So a little flat top. Okay? So again, you could do all kinds of stuff. That's enough for now. Now you want to take the bottom off. And then I want to use a tool that is in Artisan. It's called the Crease tool. So going left to right, I draw marquee. I've selected the entire bottom of this shape. I can then go to Tools, Artisan, Crease Selection, choose Edges and Vertices, say OK. And basically what that means is that now when I run Artisan, which I'm going to do in just a second, this bottom triangular shape will not be altered, which is we don't want it to be. So I select everything, just choose the Smooth, Subdivide and Smooth tool. It's this tool right here in Artisan. That's irritating. Okay. And I'm going to do 3 iterations. And there we go. And you can see that triangle is maintained perfectly on the bottom, which is very cool. And you'll see that that shape is now also showing up here. Right? It's actually up there the whole time, so that's kind of cool. So then I'm just going to move this over here as a shape to be printed or to export the STL, create an STL from that. And then I would continue on with the next shape. Now this is what I would do if I was doing it by myself. If I were doing this in a classroom situation, what I would do is for each of these, I would I would start with the icosahedron without any of these shapes on it. I would just go around. So I think this step would be confusing for students. So for each of the surfaces, each of the faces, I would go through the process of making, do this again quickly. I would make a component. We'll call this one F4. replace selection with component, right? Pull off a copy, go through that process of aligning it. I'll do that again so you can see it. Tools, align. So click corner, corner, corner. There it is. And at this point, I would save a copy of the file as like save a copy as face F4. And then I would give that to a student. That copy, I would have gone over with the students how to modify the shape. And the student would then make the modifications to face 4 here. And then you could take a look and make sure that it fits within the build box of your printer. And check that, you know, they've removed the bottom and everything looks good. And when it does, then they could send you the file. And you could, just so that if you wanted to see what your shape was going to look like before you print it with all the different extrusions, then from their file, you could select the shape that they created. There would just be one in their file. You could copy it, then go to your master file and do edit, paste in place, and it will put their shape exactly onto the plane that they're working on. Right, so you could accumulate them all as you get them back from the students, so the students could see what their shape is going to look like, and if anybody wanted to make modifications to their shape, they could do that. Okay. A good idea is, before running Subdivide and Smooth, make a copy of the proxy shape, and then if just by selecting and then pulling off a copy, each student would do that. And then if they decide later that they want to make some change in their proxy, I mean in their shape, they could go back to the proxy and just make the changes on the proxy, and then rerun Subdivide and Smooth and get the shape again. Okay, with the modifications. So so you would print 20 of these, and then you would, on the back of each one, you would drill a hole in the center. You would affix with glue this LED holder, and you would put hinges. You have to make sure that you offset the hinges correctly, right? On one triangle it's bumping into another. One triangle gets them out, and the other triangle in. It's fairly easy once you get going with that. And then you would hook them up with dowels, and you could get a really nice looking pendant, which would be easy to wire up with the lights, and you could then drop a wire from basically a box, and in the box you would have the Arduino and the power supply, and then actually 4 wires would come down. Because this would be very light, you could just use the power wires. Use like 24 gauge wire to hold this up, and you would have a beautiful light pendant. So I think there's some interesting possibilities here, and I hope somebody will do some experimentation with this. Thanks a lot for watching.